Hello everyone, I am Dr. Himamaheswara Rao, Assistant Professor of Physics, Department of Freshman Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Here we are going to discuss evolution of the atom, continues to the earlier lecture, Introduction to Atomic and Molecular Physics. These are the contents of presentation: spectroscopy, the concept of the atom, the role of kinetic theory of gases for the evolution of atom, Dalton's law, and then references. In the earlier lecture, we discussed about what is spectroscopy. Spectroscopy means it is a interaction of electromagnetic radiation with matter. So, in this phenomena of interaction of electromagnetic radiation with matter, we have two kinds of things. One is material, and another one is light. So whenever light interacts with material, we are studying about the interaction of electromagnetic radiation with matter. The two kinds of things are there. One is matter and the second one is light. So in order to understand or to have clear idea about in this type of interaction, we must know about matter and light individually. So in case of matter, it is a composition of several atoms. In general, several atoms are molecules, and again in the case of light means it is also a composition of several photons. It is a composition of several photons. Here in the case of matter, all atoms may be of different kinds. That means all atoms are of different elements, maybe of different sizes and different masses. And the property of this material depends on the composition of these atoms. These atoms are also again may be spaced with different lengths. So the property of material particularly depends on the type of atom and their spacing, sizes. So it depends on several characteristics. And again, if we come to the light, if we come to the case of light, here also there are several number of photons. Light or electromagnetic radiation, it is the composition of several photons, and again these photons can have different wavelengths and frequencies or energies. So the radiation energy of this radiation depends on the frequency or wavelength of these photons, and characteristics of this electromagnetic radiation also depends on those particular properties. So we must discuss these things individually. First, in this particular lecture, we discuss about the matter. So for the first time, atom is the composition of several atoms. So what is atom? For the first time, the concept of atom is discussed by the philosophers Lysippus and his disciple Democritus in the long back years before Christ, 440, the ages of 440, that means before Christ, very long back. For the first time, these two philosophers discussed about the atom. So particularly according to these two philosophers, any material or any natural bodies contains infinitely small particles which cannot be divisible, and whole volume of the body or natural any material is filled with these infinitely small particles. And these particles are called atoms. Why? Because atoms means, according to Greek word, atomos means indivisible. So atom means it is a indivisible particle. We cannot divide the particle more than further. Okay, so from that time onwards, the word atom is going to come came to use. So outside the atoms, according to these philosophers, one more thing is that outside the atoms, there is only the empty space. There is nothing, only empty space. That means vacuum out of the atom. Outside, if you come out of the atom, there is no any material. That means empty space. So he's the Democritus. Okay. So still, according to these philosophers, different atoms, different size and shape, and the characteristic properties of the matter are according to this model due to different arrangement of equal or differing atoms. Atoms can be different in sizes and shape. So, if the size of the atoms may be smaller to larger, okay. So, and property of any material depends on the uh, size of the atom present inside the material. So, and again, all observable changes in the microscopic world are caused by the corresponding changes in the atomic composition. So, the observable changes of in the microscopic world changes can be defined by the corresponding changes in atomic composition. If you change the composition of the material by atomic level, the properties of material also changes microscopically. And again, it is also noted that atom movements and collisions between atoms create and modify matter. So if there is any changes in movement or collisions, if there are any collisions, it also defines the modification of the matter. For example, in gas materials, if there is any gas inside a container, so they move, and the separation also very large in case of gas. Atoms separation of the atoms is very large, and they move from here and there and may collide with walls of the container. So this is the condition of gases. In case of water, the atoms, the separation or distance between water still less than gases. In case of liquids, the gap between the atoms is still less than that of the gases. So, properties of liquids are somewhat different from gases. And in case of solids, all the particles are very near, close to each other. And again, the material is rigid. So this is the and again, properties of solid materials is entirely different from that of the gases and liquid. So these are the discussions according to the scientist Leucippus and Democritus. And after that, a great philosopher named Plato also pushed some other concepts. According to his hypothesis, there are 4 elements called fire, water, air, and soil, and these are attributed as elements of the atoms. And again, he also gave some particular mathematical shapes also for these particular fire, water, air, and soil. That is another thing out of this concept. And again, later, Aristotle, one more philosopher, Aristotle is the student of Plato, and he did not accept this concept. That means the 4 elements like fire, water, and air, soil this concept according to Plato is wrong, because it is contradiction to the idea that space is filled with matter. According to Aristotle, the space is filled with matter. So his idea of Plato's idea is in contradiction with the idea of Aristotle. So he did not accept the concept of Plato. And he also believed that the existence of empty space between the atoms. Okay, so between atoms there is no space according to the Aristotle. Later, Epicurus, who attributed atoms not only size but also mass to explain why bodies fell down. So according to Epicurus, atoms are not only attributed with the size but also mass. Mass is also associated with the atoms. That is the reason for falling down of the objects to the ground. Because of presence of mass, objects are falling down to the earth. So later on, after Epicurus, there is no much evolutions of the atom or concept of atom, because due to the influence of Christian church, which did not accept the materialistic view that everything, even human beings, every material or human beings, according to Christian church, is that it is the creator. God is the creator of every material. This concept is objected by those beliefs. So due to that objection, there is no more evolution of atom. Still, there had occasionally been attempts to revive the atomic idea, partly introduced by Arabic scientists, but they did not succeed against church suppression. Still, such a suppression is there, so there is no more evaluations of this concept of atom. After that, again in the 1348, this is one example for the objections of Christian church. For example, Nicholas of Aeronautical in France, who was forced in 1348 to withdraw his newly developed atomic concept. So the large shortcoming of all these philosophical hypotheses was the lack of experimental guidance and support and proof. All these concepts are not supported by any experimental results. So there is no strong support. So real breakthrough of modern atomic physics was achieved by chemists in 18th century. They found for many chemical reactions by accurately weighing the masses of reaction products and their resultant reactants. So by weighing the masses of reaction products and their results could be best explained by the hypothesis that all reactants consist of atoms or molecules that can recombine into new molecules. So this is a breakthrough in the 18th century about the concept of atom. So besides this increasing amount of experimental evidence for the existence of atoms, the atomic hypothesis won a powerful ally from theoretical physics when Rudolf Julius Clausius, James Clerk Maxwell, and Ludwig Boltzmann developed the kinetic theory of gases, which could derive all macroscopic quantities of gases such as pressure, temperature, and specific heat and viscosity, etc. From the assumptions that gas consists of atoms that collide with each other and with the walls of the container. So according to kinetic theory of gases, all gases contains atoms, and these atoms make collisions each other and with the walls of the container. And according to this concept, they can give the macroscopic quantities such as pressure, temperature, specific heat of solids, solids and viscosity. Particularly, temperature is a measure of average kinetic energy of the atoms, and the pressure represents the mean momentum of atoms transferred to the wall per second per unit wall area. So, based on kinetic theory of gases, there is a more strong proof for the concept of atom. So, there must be atoms according to kinetic theory of gases. And after that, the English chemist John Dalton recognized after many experiments of quantitative analysis and synthesis for various chemical compounds that the mass ratios of reactions forming a chemical compound are always the same for the same reaction but may differ for different reactions. So the scientist John Dalton, he did a lot of chemical experiments. So according to his chemical experiment, he observed that the mass ratios, he calculated mass ratios separately individually for all reactions. So according to his observations, the ratios of reactants, the mass ratios of reactants are always same for the same reaction. For example, 100 gram of water, if you take 100 grams of water, always formed by using 11 grams of hydrogen and 88.9 grams of oxygen. So hydrogen content is around 11.1 gram in the 100 grams of water and 88.9 grams of oxygen. So the mass ratio of the reactants is 1:8. Even if you take 100 and 200 grams, 500 grams or 1000 grams, whatever the amount you are taking, the mass ratio must be always is equal to 1:8. And again, in the case of copper oxide, if you take 100 grams of copper oxide, it contains 79.9 grams of copper and 20.1 grams of oxygen with mass ratio of about 4:1. So these mass ratios always follow the same. So, but for some time, these mass ratios may be differ in such a cases as like magnesium oxide. They can take reaction in different ways also. There may be 4 or 5 types of reactions. In those cases, maybe the mass ratios may differ. But that means their reaction kinetics are different for each reaction. If the mass ratio is different, means the reaction is also going to change. So all these kinds of experimental results support to the concept, hypothetical concept of atom, given by many scientists from the long backward onwards. So finally, there must be atom. That means any material is a composition of several atoms, and these atoms can be of different sizes and different masses. Okay, and again there may be separation distances between atoms. The properties of any material depends on the type of atoms, mass of the atoms, and separation between them. These kind of properties plays very important role in the finding the property of materials. So with this, we came to idea about the atom, and in the next lecture we will discuss about the electromagnetic radiation. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.